Hi, everyone. Welcome to the Stratum Techinar. My name is Brian O'Connor, and I'm the technical lead for the Stratum project at ONF. Today with me, I have Max Budelko, who's been our leading developer and contributor to the Stratum project. If you've contributed code in the last couple of years to Stratum, Max has probably been the one who's helped you with reviewing your PRs. So today, our plan is just to give a quick overall introduction to what is Stratum. Most of you on the Techinar hopefully have a good picture of that, but for the newcomers, we just summarize it briefly. We want to provide some next highlights for the last two releases that we've had. Our March release and our June release. There's a number of new things that came along, a lot of user-facing enhancements that we think you'll really enjoy. Next, we'll talk briefly about the roadmap, where what we've done so far this year and what we plan to do in the next 6 months or so this year. And then lastly, I want to put Stratum into context, provide a little bit of the broader landscape, switch OSs, and how we're bringing Stratum-like capabilities to other places as well. So let's get started. First off, what is Stratum? So as many of you probably know, it's an open source, production targeted thin switch OS. And by thin, we really mean two major things. The first is that you bring your own data plane in the form of a P4 program. And the second is you bring your own control plane that's going to program the entries at runtime to control the forwarding and routing that happens on your device. So there's no BGP, no LACP, there's no other in-band control plane apps installed on the box by default. And there's no default pipeline. That's depends upon the hardware that you're using and the applications that you want to run on it. To help get you started, if you want a full networking stack, we have a fabric.p4 program. We have a control plane called Onos and a suite of routing apps called Trellis that do BGP and other routing apps, routing control that you can put together to form an SDN style networking solution. On the interfaces side, the main interfaces that Stratum exposes to users and the control plane are these ones. So first we have P4, which is a domain-specific programming language that helps you define very specifically the data plane. And we've shown that P4 is good for both modeling fixed function data planes as well as defining the forwarding behavior for programmable data planes. To control this data plane at runtime, we have an interface called P4 Runtime. It's a gRPC service that runs on the switch and exposes the capability to modify the forwarding plane at runtime. You can use this for apps that are running on the box or ones that run off the box. On the configuration side, we have OpenConfig, which provides a rich set of models for ASIC and platform configuration, as well as enhanced telemetry. And then to get access to the configuration and telemetry at runtime, we have GNMI, which is a gRPC service for monitoring the device and configuring it. So hopefully that's a whirlwind tour. And let's move on to the release highlights. So as I mentioned before, the focus of this talk today is to focus on our last two releases and the features that we've added in those releases. This represents Stratum's 4th and 5th release. That's 21.03 and 21.06. We're currently in the process of working towards our 21.09 or September release. And just a reminder, with Stratum, we're not really into the long-lived LTS support branches. We've got a philosophy, which is we like people to be living ahead. We want to have our development team and our community be fast-moving and adaptive to new changes and requirements. New development, bug fixes, everything happens on main. That's where PRs come in. And then what we do is for deployments, we provide periodic releases. So these are quarterly releases, and they follow this year-month format. If you're looking at the source code, you'll see tags, which are fully qualified year, month, day. And we've got automated scripts that take care of building and uploading all of these artifacts to GitHub and Docker Hub for deployments to take advantage of. So a quick note on release notes and artifacts. if you haven't downloaded the release notes before or taken a look at the artifacts that we prepare, this link here, github.com/stratum releases, has a list of all of the releases that we've had and will contain future releases. If you want Debian packages for our supported targets, they're under the assets section, which is under the GitHub release. And then if you're looking for Docker images, those are uploaded to Docker Hub, and you can find most of them under the Stratum project org. Moving on to some of the actual features. The first is some of the APIs in the last couple of releases have been enhanced. So if you're a Stratum user from the very beginning, you will have known that we were kind of squatting on a port when we got started. The default Stratum port was 28,000, and we're no longer listening to that by default. Fortunately, both GNMI and P4 Runtime have IANA standardized port numbers now. 9339 is for GNMI, 9559 for P4 Runtime. And so we're recommending that users move over to those in almost all scenarios. If you do have a dependency on the 28,000 or want to use some other number for whatever reason, you're welcome to override this using this external Stratum URLs flag. On the P4 Runtime side, we've moved to version 1.3.0. There are a number of small enhancements that came along with that, but one of the biggest changes that came along with that move for us was a move to canonical byte strings. More on that in the next slide. On the GNMI front, there's been a number of fixes. Check out the release notes for all the paths that we've made fixes for. A lot of them are enhancing the capabilities of the interfaces subtree to control and ports and look at statistics. But the other thing from a user perspective that you might find helpful is the log level can now be updated at runtime. So if you're running Stratum on a box and something's not going quite as you hoped or planned, you can drop the log level to a lower level while you're in your debugging session, and then put it back to a higher level to reduce the amount of log output. We found this to be pretty helpful in our staging and test pods. Moving on to P4 Runtime and the canonical byte strings. Previously, Stratum and P4 Runtime services in general used full binary width strings for integer values. So when you're inserting a match action table entry or a meter entry or any one of the P4 Runtime pipeline entities, each of those fields had a size, and they could be 32-bit wide fields or 16-bit wide fields, and you had to fully specify the whole string in order for P4 Runtime to accept it. BMB2 and Tofino, for example, were two targets that required this, and you had to go and pad this out. You had to look up what size is this individual field and then pad it to the appropriate size and send that on the wire. That's changed in newer versions of P4 Runtime, and Stratum now complies with this. The spec calls this canonical byte strings, and basically it means byte strings that are not padded with leading zeros. So if you have a control plane app that uses Stratum, you'll want to upgrade to this non-padded format. It turns out, like at least in the ONF control plane apps, it actually meant removing code. It's a lot easier just to generate a non-padded string. Now, if the target SDK still requires padding, and some of them do, Stratum will take care of padding these out to the full widths that the SDK needs. So you don't have to worry about that at all. Now, Stratum is still flexible. You can write full width or canonical strings as part of your entries to Stratum, but reads will always return the canonical strings. So we recommend moving to canonical strings for a number of reasons, but one of those is read-write symmetry. So if you want to make sure you are reading back what you wrote, use the canonical ones. Moving on to log level. This is a topic that's probably a little bit more confusing to users than we would have liked. So I'd like to spend just a minute on that. The logging library that we use in Stratum is called glog. It's from Google, and it's pretty widely adopted in the C++ community. glog gives you two knobs that you can set at runtime, or sorry, at initialization time via command line flags. One of them is called severity, and the other is called verbosity. By default, info is the severity and verbosity is set to 0. What we've added to Stratum now is an ability at runtime using GNMI to change the log level. And so in that case, we're using the OpenConfig model, and that has a definition for logging severity. And to kind of help clean up the mental picture that you have, we have this handy chart. So the default level in OpenConfig is notice. That corresponds to info on the severity front and 0 on the verbosity front. As you go up, so as you want to see fewer and fewer messages and more important messages, we go from notice to warning to error to critical on the GNMI OpenConfig front, and info warning error fatal on the glog severity side. In debugging, you may want to see more information, and that's where you leave the severity at 0 or info, and you increase the verbosity of the component. So yeah, hopefully this isn't terribly confusing. glog has some documentation that explains it, but generally speaking, glog kind of pushes you in two directions: severity up, verbosity down, and we've mapped that all to one common, easier to understand scheme from OpenConfig. Now, if you actually want to get and set the log level at runtime, we have this Stratum tools container with a GNMI CLI tool. So you can use that toolbox to get the log level by providing a GNMI get request to the system logging console config severity path. And then if you want to set a new value, you can just use the same tool to write debug or warning or error, whatever log level you'd like to specify to that same path. So that's it for the API enhancements. Hopefully you'll find those to be useful and improve your control plane interaction. And next, I'd like to turn it over to Max to talk about some of the enhancements we've done on Tofino and for debuggability.
Okay, thanks, Brian, for handing it over to me. Like you said, I'm Max. I'm the lead developer right now on the Stratum project. And now we're going to talk about a few of the Tofino enhancements that we made over the last few releases. Yeah, like you can see, we continue our story of taking full advantage of the Tofino ASIC capabilities far beyond just match action tables. That was really just one of the first steps. And in this release, we focused on 3 parts. The first one is P4 runtime meters that usually live in the ingress match action stages here. And they allow to dynamically color mark flows according to either byte or packet limits. So it's a really convenient feature, and we managed to expose that as a standard P4 runtime entity. So it's fully standard compliant right now. The second part is the second modification we made is that we now expose the traffic manager that sits in the middle between ingress and egress. We now expose the traffic manager APIs as part of the chassis config of Stratum. Currently, this allows direct and pretty much unmodeled access to pre-advanced features like application buffer pools, PFC priority group or PPGs, and just the plain queues that connect to two pipelines. Like I said, this is currently unmodeled, so we don't impose any structure. It's pretty much just the raw Tofino SDE or SDK APIs. We just map them through. But in the future, we might refine this into a model, for example, the OpenConfig one, as we see fit. But for now, the current implementation allows allows the user to put some pre-advanced quality of service rules into place. And that's actually what we're doing in the Ether project, where we try to prioritize 5G mobile phone traffic according to certain rules, voice over data, for example. And as the last step, we enable port shaping on egress ports. which again allows to impose limits, byte or packet limits on egress ports, mainly to just prevent overloading downstream links, because just because you have a 100 or 40G link, that doesn't mean that all devices downstream of that link might actually support that. So it's easier to just impose a limit here and drop the packets early, or just not send them at all so they don't get dropped. So that's on Tofino, the first part. Next, we focused on platform support, or BSP. On the left side here, you see the current model, how we start and configure the Tofino SDE, which is the development kit that allows us to talk to the actual switch here. So it sits between Stratum and the switch. What we currently do is we pass in a static port configuration out of band into the SDE on startup. It has a few drawbacks. First of all, it's fixed after startup. You can only do it once. And if you want to configure certain values afterwards, for example, transceiver types or SerDes values, you really have to reboot. And that's pretty inconvenient. And another drawback is that this config file is platform and model specific. So you cannot just write it once and then reuse it. It really depends on what type of switch you have and what manufacturer. So it's very specific. What we did here in this release is to replace that with the BSP, short for board support package. And this is usually a vendor-provided piece of software that plugs into the SDE and bridges the gap between switch and platform specific parts and Stratum. So in particular, the BSP discovers and dynamically sets the configuration depending on the available hardware. So for example, if you have a copper transceiver, it will look into a database and configure it appropriately. If it's an optical transceiver, it will do the right thing and make the optical transceiver work. This means that for the first time, we have out-of-the-box support for optical transceivers. So they should just work. And previously, this was pretty tricky to get working. In the future, we might expose advanced platform features, for example, LED configuration on the front panel ports, or SerDes value in general to fine-tune parameters for perfect transmission. On a higher level, using the BSP allows us to be independent from ONLP, which continues our story of platform independence. And in the future, we might be able to run on completely different platforms from ONL, like a standard Ubuntu. Okay, with that, I will go over to the debugging enhancements. Here we continue to continue our usability story by increasing the usability of Stratum for non-developers. We really want to really want to empower users to be able to use Stratum without being super intimate with the actual code base. We did a couple of steps to facilitate this. First of all released Docker images now include labels to trace their origin. So if you encounter a Docker image and you're not sure where it came from, what version it is, where it was built, and when, that's all now possible. I will show all of that in a second, by the way. In the same way, all the binaries that we release and that are built with the release configuration now include stamped in build time information. Again, this is like timestamp, the machine, and the version git hash of the source code. So the third improvement that we made is adding a small convenience script that allows easy remote access to the Tofino shell, Tofino BF shell. A lot of tutorials or advice on the official Intel forum assume that you have a shell open or at least available to you, and then if you start Stratum in the default configuration, such a shell is not there and it's hidden. And that confused a few people, so we made it available here. And lastly, we collected many of the auxiliary tools that we wrote over time and released them in one convenient package. So we just went over our source code and looked at all the small tools and helper functions, just packaged them together. Right now, or for a small selection, it contains the GNMI CLI if you want to modify parts of the OpenConfig tree. The BF pipeline builder, if you want to package a pipeline, a Tofino pipeline ready to use inside Stratum, and Stratum replay if you want to debug a flow state on a different device or just want to replay it again to look into an issue in a little bit more detail. All these tools, or this tools container is released as a Docker image on Docker Hub under Stratum project/Stratum tools, and as a Debian package if you want to build it yourself. It's just Stratum tools that can install pretty easily, which I will show now. So let's do a quick live demo here to show how easy it actually is to do all of that. Okay, so what we have here is a terminal window on a switch, on a live switch, hardware switch that we have running in our lab. And on the left side here, I have a running Stratum instance that's been running for a while. And I just noticed there are some errors here, and I want to figure out what's happening. So as a first step, I will try to figure out what version I'm actually running. So I will open a second window here and just do a Docker inspect on the Stratum image, on the Docker image that I have deployed on the switch to figure out what more information I can get. So Docker inspect, and we use the JSON format, so it's a little bit easier for us to parse. And we're just interested in the labels here. And we run that through JQ for visibility. So what we get here is the list of all the tags that are attached to that image. And we can see, for example, that the SDE version is in here. We see that this was built on this build machine. It doesn't tell us too much, but it might look familiar to our CI system and might give us a good hint. The timestamp here is interesting. So we see that this image is roughly 5 days old. So we know roughly where it comes from. And most importantly, it gives us this checksum here. And this is a git commit checksum. I can just plug that into Git and get the exact version that of the code that is deployed right now. So if we go back to here, you might see that the log contains file names and line numbers. And together with the checksum and the source code, I can now figure out, or I can now pinpoint the location where I have to start looking, which is pretty convenient. Okay, let's go back here. The second thing that we did was the stamping of binary information inside the binary directly. So if I restart the instance here again, you will see that the first log line of the first line of the logs now always contains this string here. So we will always print the Stratum version. Again, that's the commit hash, the build timestamp here, and the host it was built on, and the user who built this particular version. So if somebody sends you a log, or if you're looking at a log of a failed or crashed instance, you just scroll to the top and look at the first line, and you will get all the information you need to continue debugging. Then, okay, let's see if that's started up. Okay, it should be running again. Let's see, we want to do a live debugging session, and we want to attach. So we want to, so somebody sent us a few BF shell commands, and we want to try them. Right now, as you can see, I can't really enter anything here because the shell is not available. So I go back to my second window right here and run attach bfshell.sh, which is a script that is by default just installed with Stratum itself. So you should have it. So you run that, and it automatically connects to the running Stratum instance, and now allows you to start the uCLI. And then you can run the normal commands as you would normally do. For example, I am printing the port map here. So we see that we have a couple of ports and they are all up. But let's say one of them were down. We have now full access to all the commands that we normally that the Tofino CLI makes available to us. Okay, let's exit this and let's go talk about the tools container. I talked about how we bundle all the Stratum tools, and If you build that container yourself or want to use the Docker image, you just load it onto the switch, and I will just install it real quick. 1 sec. So I will do that. So you just do apt-get install and Debian file. It's a standard Debian package. It should now be here. And now I can use, for example, the GNMI CLI to look at the status of one of the interfaces. Of course, it doesn't work. Probably some port issue. Maybe I started on a non-standard port. Okay. Well, the demonstration here was that the GNMI tool is available, among others, like the BF pipeline builder. And if you want to use those, that's how you get them. Okay, and with that live demo, it concludes my part, and I will hand it back to Brian for the roadmap.
Cool, thanks, Max. All right. So just taking a look at the roadmap, this slide is the black text is a slide we presented to the Techinar back in January. And really there are 3 major areas that we're looking to make enhancements to this year. The first is we want to support production users. That's been our top priority as a community. For that, it's been a number of new features. So as Max mentioned, we've made good progress on QoS modeling, exposing additional Tofino features like the scheduler and traffic manager, traffic shaping. And we've also continued to make external API enhancements that have been required by some of the control plane applications. We still have plans to improve testing throughout the year. I mean, testing is kind of a continuous thing, but we don't have any major updates on that to report so far this year. Our second major initiative was portability. So we want to make sure that the control plane interfaces or control plane applications that connect to Stratum are going to be portable across different API implementations. And for that, we want to move away from things like chassis config to the standard open config model for configuring devices. We also want to make Stratum more ubiquitous. We want to make it run on more platforms. We want to make it run on more base distros. We want to support more plugins like transceivers. And so with the BSP support that Max described, we're really taking a first step towards improving or enhancing our story for increasing platform support, peripheral types, and base distro. And then we also want to run and test some of these capabilities on other switch OSs. That's planned for maybe later this year. The last area we wanted to focus on was usability. And so this is where documentation and tooling are super important to users. We've tried to collect a nice package of tools to help folks that are just running or debugging their systems to get more insight and visibility into what's going on. The community has contributed some enhancements to improve Tofino model usability. So there's now a a Mininet integration where you can run Tofino models. We're also looking at automating the P4 program linking so that the Tofino model logs are more sensible. So that work is ongoing, and thanks to the community members that have been working on that. And finally, we wanted to improve build and release automation. This both helps the ONF team that's managing releases to be able to spin out new packages quickly, but we also wanted to make it possible for folks that are using Stratum in their own environments to build a package in a quick and easy way. And so those scripts are all available now on GitHub. Diving into portability a little bit more, we have a goal that you can run Stratum anywhere. Maybe not anywhere, but anywhere that you have a switch ASIC is perhaps the goal. So we've been largely trying to reduce our dependency on ONLP, which is the ONL platform API, over the last 6 months or so. This will give users more choice. You don't necessarily need, or the goal is not to require the use of ONL, Open Network Linux, as the base distro. We've had requests to use Ubuntu, Debian, network grade Linux, which is a new project that's getting started, Sonic, and other platforms as the base distro, and they want to run, or users want to run Stratum on top of that. So we're working towards that. Part of running on different distros means supporting different kernels. The Stratum binaries already support several different kernels, and it's fairly easy for us now to add more kernels into the packages that we create. So users can build for their specific kernel if they're running a custom distro, or we can work to grow the list of kernels and include more kernel mods as part of our package. We also see BSP as a major step forward in terms of improving portability because it gives us access to peripherals, as Max was mentioning, without necessarily needing the ONLP library. So we have support for the Wedge 100 series platforms in the 21.06 Stratum packages. Vendors who want to build Stratum packages for their platform can include the BSP now. And we're currently exploring ways with the community to package multiple BSPs into the same universal Stratum package that we release on GitHub and Docker Hub, just like we do for multiple kernel modules. So that's a bit on Stratum and sort of our roadmap for this year. Next, I want to transition to the Switch landscape. So maybe zooming out a little bit and looking at how Stratum fits into a broader community of developers that have been trying to add these types of capabilities to boxes. So the first up is a project you may have heard of, or maybe not. It's called PINS, which stands for P4 Integrated Network Stack. It's a collaboration with a number of community members that got started by Google, Intel, and ONF. It's now grown to include other operators and vendors. And the goal here is to bring P4 runtime to Sonic and to model Psi using P4. There are a number of advantages to doing that, but I'll let you take a look at the provided link after the talk to understand a little bit more of the value prop. Summarizing briefly, PINS enables a hybrid control plane, so traditional plus SDN working together on the same switch OS. It provides an incremental opt-in path to SDN. So if you're running a traditional network, it gives you a chance to take small specific steps towards making more of your network SDN ready. And it allows for Psi extensions to be modeled in P4, which is a much faster process than the current C-based approach. So we're hoping the PINS community is planning to have some design docs available soon, and then is hoping to include an MVP as part of Sonic's November 21 release. So that's coming up at the end of the year. There's a lot of opportunities for overlapping opportunities between the Stratum community and the PINS community. And two examples I wanted to call out. One is the P4 runtime server. So both need to implement the P4 runtime spec, and there's a lot of details in the server around client arbitration, role management, entity management, et cetera, packet ins, packet outs that's kind of shared between these platforms. And so we're looking to provide a common standalone library. And these two projects are kind of, we're using them as the basis for this library. And the second thing is testing and validation. We've already been collaborating between these two projects to look at ways where we can benefit from each other as groups to improve both platforms. We've used some Stratum tests to find bugs in PINS, and we've started using PINS test cases to cover some Stratum areas as well. Moving on to the next project is one called P4 OVS. This is a collaboration between Intel, Orange, and ONF, looking to bring P4 capabilities to the Open vSwitch. There's some talks on this that were given at OVSCon last year. We'll provide some links to these in the notes, so you can follow up if you're interested in learning more. But just briefly to summarize, the goal here is threefold. One, to add P4 runtime as a partner API to OpenFlow, and then provide translation between OpenFlow and P4 runtime, so that users of OpenFlow control planes with OVS solutions can slowly migrate components over to P4 runtime over time. The second is to more precisely model the OVS data path in P4. Doing so for specific use cases allows us to have a better understanding of which match action fields go where and how many table stages there are, etc. When you're running on CPU, that doesn't matter too much. But once you move into some of the P4-enabled targets, such as SmartNICs, FPGAs, and ASICs, having a precise model of the pipeline is essential for realizing that on hardware. So that's the third part, is really to grow the set of targets that or backends that OVS runs on. eBPF and DPDK are both P4 enabled now through compiler enhancements to the upstream P4 compiler. We're also seeing SmartNICs, FPGAs, and Tofino as all possible target or backends for OVS as well. So we're planning to have a POC on that later this year. It's still in early stages of development, but something to be looking out for if OVS is something you've deployed. Again, there's a lot of opportunity for overlap, and there's already ongoing collaboration and communication between the Stratum team and P4OVS. For example, the P4 runtime server in P4OVS is Stratum's. That's the starting point. No need to reinvent the wheel and rewrite something. In terms of the backend mapping, going towards Intel's table API, sometimes called BFRT, that translation from P4 to the table API is something that we did in Stratum BFRT, and that code is something that we're sharing and reusing in the P4 OVS project. So yeah, there are other opportunities as the project evolves as well, and so. I guess the picture that we're trying to paint here is there are initiatives and outside of Stratum, but we're working closely to reuse pieces and share libraries and components as we can. So with that, what I wanted to do is just provide, at least for these three projects where we're talking about adding P4 and P4 runtime capabilities, a little bit of a differentiation between why you would want to look at one versus the other and what the value is. So Stratum, as maybe you've already gleaned, bring your own pipeline and control plane. This is great for pure play SDN networks. It's also great if you have a highly customized pipeline. You wrote your own pipeline, it's yours, and you want to deploy it on a lightweight, high performance, low footprint switch OS. That's really what Stratum's designed for. Moving on to pins, which is a feature set we're adding to Sonic. The goal there is hybrid control planes and a path to SI extensibility. So this is great for traditional network users who have Sonic or something like it deployed and want to start to experiment a little bit with SDN for small parts of their network. Obviously, we want to be able to grow that to the whole pipeline. So you could be fully fledged on the SDN front, or fully on the traditional front, and it's just a knob you turn, and that's where we're marching towards. The goal here is also to provide a more seamless transition. We don't want to have greenfield, rip out everything and redeploy for these deployments. We want to be able to just incrementally add new features that bring value to the use cases for these users. And finally, P4OVS. The goal here really is to optimize OVS by running on P4 enabled targets and to modernize the control interface to be P4 runtime. So this is great for OVS users who have OpenFlow control planes and use OVS DB to configure their devices. This is really designed for the server and has a wide range of supported targets, CPU to switching ASIC with SmartNICs and FPGAs in between. So a slightly different target user base. But if you are looking to bring more P4 capabilities and P4 performance to your devices, that's something to look at. So what these platforms all have in common is we're using P4 as a common language for pipeline definition. This is helpful for modeling fixed function ASICs or logical pipelines like SI, as well as extensions. So adding new capabilities to the pipeline by the user or operator at runtime. The second is we're seeing common SDN-ready interfaces across these platforms. P4 runtime and GNMI with OpenConfig, for example, are becoming more ubiquitous. And this is really good for control plane writers who want to be able to port their apps across different platforms they may be running against. We're looking for ways to share code, libraries, and test cases. P4 compiler is common. We're looking to make the P4 service more standalone, so that can be plugged into different platforms. P4 to table API translation, where that's needed in these various projects. We want to be able to reuse code there. On the tool side, there's test frameworks like PTF. There's command line shells like P4 runtime shell or GNMI shell or GNMI CLI that can be used across these projects to inspect and manipulate and develop the platforms. There's a lot of community overlap already. There's companies and individuals that are involved across multiple of these projects. And quite frankly, it's a small community. We're growing, but in the grand scheme of things, SwitchOS doesn't have hundreds of thousands of developers. So where we can pool our resources and pool our mind share, everybody really benefits. So trying to improve collaboration and reuse code means there's more cross-pollination of ideas, less development time. For example, P4 OVS, without having to develop a new table API translation and P4 runtime server, is a lot further along than it would be if it didn't have that. And one of the other benefits of open source is reduced maintenance burden. So if we have shared code, people find bugs, fix bugs, everyone benefits by pulling in the latest. So hopefully that's provided a little bit of a preview to some of the other Switch projects that are kind of overlapping with Stratum. And I think you'll learn more and hear more about them as we go. So I'd encourage you to follow along and try to see how these other projects evolve, and maybe they're well suited for your use case. The goal here really is to find projects that fit the use cases that users require and provide high quality interfaces and high performance solutions. So how do you get involved? There's a number of ways you can do it, and I'd highly encourage you to look into these if you're having questions or developing new features. First off, there's a mailing list and a Slack channel. If you click on the links in the deck after we send this out, it'll take you to register for those. We have a weekly TST meeting, Thursdays at 12:30 p.m. Pacific. We often have pretty good technical discussion. It serves both as an opportunity to review design proposals and cover community kind of areas of interest and questions. So if you have questions and want to talk to Max and I live, I'd encourage you to join one of those. Obviously, send pull requests. That's the mantra for open source projects. If you're just getting started, we have a great tutorial called the Next Gen SDN tutorial, which will walk you through Stratum, P4 runtime, all the various components. And finally, a new plug is if you're a vendor out there and have BSP support or BSP for your platform, add it for Stratum and let us know. And we'd be happy to find a way to package as part of our universal binary. If you're interested in pins, it's currently an ONF members only project. So there's some information about it on the ONF webpage. We're planning to open it up later this year as we include the MVP as part of the Sonic project. And then P4 OVS is currently incubating with a small team. So there's some folks that have given talks on the Intel side. They would be great folks to reach out to if you're interested in getting involved. So with that, I think we're ready for some questions. Just looking through the list here. The first question comes from Miguel. And the question was, there's a pull request in the Stratum GitHub repo that brings in the pins P4 runtime server. Well, why is that being done? So great question. The pins P4 runtime server has actually implemented some advanced features of P4 runtime that are just not yet part of the main spec. It's an area called roles, which allows you to have different control plane apps controlling different parts of the pipeline with access restrictions on those parts. You can have a single primary client for each role, so you can have a multiple kind of active scenario with some buffers. but yeah, the plan was rather than re-implement that in Stratum, we thought that it would be better to start to collaborate and kind of meld the two implementations together, and then actually extract that into a library that could be used by other projects as well. So if there's hopefully that answers the question, but if there's follow-up, feel free to answer, to drop another question in. All right. Another question from Syed. What is meant by BT hybrid control plane? Maybe by. So hybrid control planes, what we mean by that is taking a step back. We have traditional control planes where you run BGP, LACP, everything on the box. The control plane and the data plane live together, and they coordinate through high-level network protocols like BGP to exchange information between the boxes. This is the way we've deployed networks for 40 years. If we look at the other side of the spectrum, the SDN side of the spectrum, we've kind of driven a wedge between the data plane and the control plane. And we've said the data plane is going to run on the box, and the control plane is going to run anywhere. Could be on the box, could be in the cloud, could be on a server that sits in the same rack. And the control plane is going to be what's responsible for determining what forwarding and routing is going to look like for our switch target. And so in those extremes, traditional extreme, there's obvious benefits, and a lot of people are familiar with that deployment. With SDN, there's benefits like having a global view and being able to do optimizations and coordination. What we mean by hybrid is really blending the two together. And typically, we're not blending the two together arbitrarily. We're selecting like L2 is going to be on the box and routing will be off the box, SDN style, or L2 and L3 will be on the box, and this other new feature, maybe it's ACL control, or maybe it's MPLS forwarding, or ECMP is going to be off the box. So in a hybrid control plane, we decide on a feature by feature basis, are we going to run this standard app, traditional app on the box, or are we going to do something SDN style? All right. Next question comes from Prakash. Do you have a list of hardware that you use in your lab for Stratum development projects? I noticed Mininet and BMV2 switches for software development. Curious about hardware switches and SmartNICs. Max, did you want to take this one?
Sure. Yeah, let's think. We have a pretty diverse set of hardware, but yeah, so we have a bunch of edge core devices, edge core, wedge, 100 BF, and a couple of submodels in there, like the 32X, the 32QS, and the, I think, 64X or 65X. What else? We're looking, we also have a bunch of APS network switches. I think both the 32 port and 64 port switch. And I think those are an active staging production use case in various projects. So these are, I would say, first class supported, always work and up to date. And then we have a bunch of minor or other devices that we don't actually, we don't have an active use, but still maintain. I would encourage you to check out the certification page, the CCP program certification page. There you should find a list of the latest tests and checks.
Cool, thanks, Max. Maybe you can take the next one too. The next one is any plans to move, or any plans to provide an officially supported Yocto recipe for Stratum?
That's an interesting one. I would say no, not right now. But the APS team or the NGL team, Network Grade Linux project, they have done a lot of the work to provide a Yocto-based recipe, and they include it as part of their NGL standard installation base. So you could have a look there if you can reuse parts of it. But I think for us officially, Bazel and Docker remains the right choice at this time.
Cool, thanks. Next question is from Miguel. Regarding P4 OVS, is the goal to merge the P4 support into the OVS main repo or keep it independent? So it's a really good question. I don't necessarily have all of the answers here. I think Intel's kind of driving some of the decision making with respect to that. I would say the project's sort of in an early enough stage that that's not an immediate consideration. The goal at first is just to see what can be built. And then we've already started discussions with some of the OVS maintainers. They're aware of the project, but it represents a few significant, new areas, new targets, P4 model, P4 runtime. So I think if it does go in, we'll need to find ways to stage this out in pieces, so that maybe P4 runtime is added first, and then maybe the targets come second. I guess it's still up in the air. But I would encourage you, if you're interested in the project, to check out the links to the P4 OVS talks that we'll post on the event page after the event, and to reach out to some of the Intel folks to see what their ultimate goals are. All right. Next question comes from Chris. What's the ETA for pins documentation? Great question. I can tell you that the main design doc is in its kind of final stages of internal review. I'm hoping that by early August, within the next week or so, we have that posted on the Sonic GitHub page for review. There's a number of supplementary docs that go into details around how things like packet IO are handled, how we map to SCI, P4 to SCI, et cetera. Those docs, I think, the plan is that they would shortly follow. So hopefully August is going to be a good month for getting more documentation. But unfortunately, I don't have an exact ETA to provide there. With that, I think we can close the session. Thanks for the great questions, and hoping to see more of you on the mailing list, the Slack channel, and as part of the meetings. Thanks, Max, for joining, and we'll see you next time.